Also, I told you about the textbooks which you supposed to refer for the further studies by Anderson. As I said, it is the Bible of this particular topic. And I'm going to refer most of my discussions based on Professor Ramesh's ebook on engineering fracture mechanics. But the very cost-effective edition of Prashant Kumar's book, Elements of Fracture Mechanics, also available by the Tata McGraw. So this is about your course. You have any doubts so far, Pa?
No, sir.
No, sir.
No, no. Okay. Can we proceed?
No.
No.
Yes, sir.
If you
Yes,
have
sir.
any doubt, just immediately you stop me. Okay.
Yes,
Now
sure.
you're all like you're in final this one final year, and these are all the advanced structures, something like application oriented structures, and you have to learn just by understanding the things in a better sense only you can proceed. So it's not like I'm teaching, you're simply listening. It's not like that. Don't take in that particular fashion. That won't be correct when you talk about electives like fracture mechanics and all. It's something like a mutual discussion will give you more insight about this particular subject. And we will not make it something like typical structures of typical structure of the such subject which you have learned so far from the semester 1 to 10. So this is something like you're all now a matured fellow, a senior fellow. So now some kind of interactive way only you can learn in a better sense of these subjects like this kind of application oriented subject. Now I'm taking you to the things. Now I have done the introduction about the things and so on. And before actually we go to this, um, what exactly that just a minute, I'll take you that one. Yes. Is it able to see?
Yes, sir,
Yes,
but
sir.
the font is a little small.
We will. Now,
Yes.
isn't it now?
Yes, sir.
Okay. I just want to know that. I just want to make you the what you call that course subject outcomes. Okay. After I have learned this course, what I will get end of the day, I should understand that first, no? So we are actually ultimately end of the day you will come to know that different types of fracture and also its character, okay, and how the growth of the crack and all you will understand. Then of course I told the energy principle, okay, so you will understand how the energy principle is applicable to the fracture mechanics. Also the different failure modes, how the energy approach brought the equation, so also you will understand or you will be familiar with that. Then your third attainment or outcome could be end of the day you will understand the stress intensity factor and also how the stress intensity factor approach we will see problems related to the crack available inside the material or surface of the material, something like that you will apply and also it will be demonstrated. So you will come to know that end of the day like that. And also the application of J integral, okay, J integral, and also the displacement based method. End of the day you will come to know that how the J integral is different from CTOD or the energy or the stress intensity, all those things. And also you will come to know that I told the fracture toughness. Okay, fracture toughness. So how to find the fracture toughness for different materials? What are all the procedures are available? So those kind of things you can understand. So end of the day, you will be learning, or you will end of the day you will be in a position to realize these things. Okay, that is the outcome of this particular course. Okay, right. These are all the introduction about this particular course. Now I'm taking you to the course. Now you can see my slide. Am I correct?
Yes, sir.
Good. Now, okay, you are. Let us getting into the introduction part of the fracture mechanics. In 19th century, okay, now we are something like a 20th century or 21st century, okay, getting into that. But if you see 100 years back, okay, 19th century, okay, people are have actually, the industrial revolution has come, okay. So in 19th century beginning, so people actually started using, okay, the metals, okay, for the structural applications, metals like iron, aluminum, and so on. But until then, what they were using, they were using different type of woods or clays or mud and kind of things they were using. Only in the 19th century, when the industrial revolution started, people actually were used to use the metals for the structural applications. What are the structural applications in 19th centuries? Something like, they were started about thinking about the, okay, boilers, railway locomotives, ships, okay, boat, and wheels, something like that. It all came, okay, valuation came. But what happened, okay, because they were all very inferior knowledge on the metals or the materials, okay, they found end of the day several catastrophic accidents. Okay, catastrophic accidents. That means unpredictable accidents. Okay, of boilers, railway equipments, and due to that, they okay lost a lot of life and property when all these things had happened in 19th century. So then they were actually try to, okay, study about those things, and they found, okay, the accidents actually they may because of the poor design. Okay, okay, poor design. Designing was poor. Then and later on they improved the understanding and other things, and the understanding of the materials. They have improved the concepts and they made some production, something like that. Okay, so in spite of all these things also, okay, they have come across, especially, okay, 20th century beginning, okay, a lot of actually failure came because once these kind of approaches, they have started using a lot of materials, metals for the applications. Okay, still, okay, some failures, especially the spectacular failures, okay, in 20th century, they got it. Then they understood, okay, they were thought why these kind of spectacular failures came. So worldwide people have, okay, made some committee, and they were actually gone through the, failures and understanding all these things. So finally they made a report or some kind of, outcomes. So that is where the study on fracture mechanics technique have come to the world. That is earlier 20th century. So what exactly the fracture mechanics means? It recognizes the role of inherent flaws. This is very, very important. Inherent flaws in structures that affect their performance and life. Okay, that affects their performance and life. Inherent flaw. This term is, you know, very important in the entire fracture mechanics course. Inherent flaws. Inherent flaws. That means, you know, something like you take a material. Okay, you take a material. Okay, there'll be a crack inside. Okay, there'll be crack inside. Suppose if you see a three-dimensional this thing, so there'll be crack somewhere inside. Inherent flaws. Okay, inherent flaws. Flaws means basically what? It is a crack basically. Okay, so that inherent flaws. Okay, that is the main reason for the structures. Okay, performance and life. So through which actually they have came out, okay, with a topics called damage tolerance. You can see here, damage tolerant design approach. What is damage tolerance approach? Suppose I have a inherent flaw in my structure. Okay, can I use this particular structure for my application? Okay, so that study. Okay, so that study, can I use this structure? That means the structure is having already the crack. Can I use it? That is called damage tolerant design. Damage tolerant. I'm tolerating. Why this thought has come? I told you, no, yesterday that any material you manufacture or any structure you manufacture, okay, it's very difficult to make, okay, without any damage or inherent flaws inside. It is very rare you can make without any damage. Definitely there will be some kind of discontinuity, flaws or cracks will be inside. So the development of the flaws or cracks inside may be because of the manufacturing fault, or because of the assembling fault, or because of the service fault. Anything will happen or might happen for damage may happen inside a body of a structure. So what is this damage tolerance approach means? Can I use that particular structure for my application? So one good example is, now I'm telling you, I don't know, I'm so tired now. Okay, right, sorry for that. So what will happen? Let us take the aircraft manufacturing. I hope you know that our HAL, Hindustan Aeronautics Limited. Okay, we are making, okay, helicopters, okay, fighter planes, okay, and UAVs. So many things we are doing. Okay, for one, they are making so many fighter planes. One important fighter plane, what government of India is making is Tejas, isn't it? No, you know or not, Tejas? Hello, you people, I'm asking question. Hello,
Yes, sir.
have you heard about
Yes, sir.
the fighter plane Tejas? Tejas.
Yes, sir. I've heard in news.
Yes, sir, we have here, sir.
How good you know?
It's like another Make in India project.
Yeah. So what you have to do, all three or four of you, you just briefly go through about this particular Tejas and give me one or two, three slides you have to send by today evening to me or tomorrow. Okay, some study on Tejas.
Okay, sir.
Something. You start reading something, just one slide or two slides about that is sufficient. What you have gone through that. Okay. This is your first assignment.
Yes, sir.
It should be only 2 slides. Okay?
Okay, sir.
Right. So, it is a fighter plane. So, if you see that, the what you call that, what is this particular part called? What is this? Any idea? What is this part in a plane?
Radar, sir.
Ah. Okay. Okay. Radar. So this radar, you will have the control surfaces, all these things are all there. This is movable part, this is attached part, something like that. This radar is something like a composite and a metal. Okay, it is something that a center stem will come. Okay, a pure metal that is connected to mainframe. Over that you can see this one composite. This is a structure of that particular. So making this radar itself, roughly it is about 5 crore. 5 crore, one radar for one aircraft. So this should be a single manufacturing, what you call that, process. Radar, it is something like in one shot they will make. Okay, once you go to HAL shop floor, you will understand that how this plane is being made. Unfortunately, anybody have you visited HAL?
No, sir.
No.
No, sir.
Yeah. In Bangalore, near the HAL airport, it is on the Maratali road. It's a big unit they have, manufacturing unit. There they are making so many things. In fact, India is actually developing, or all the Russian made Jaguar, those things are production line only. Okay, the license is from Russia, but Russia or European countries, we are making, Duru helicopters, so many flights used to fall, no? Those things are all manufacturing here only under the license of Russia and Mirage, Jaguar, all those things we are making. And also so many retrofitting also we do a lot of things. So that also going. But another division is mainly they're making Tejas. So these things will happen 5 crores, one this thing. Okay. So why I'm saying that means after I made the radar, once I take it to testing in the sense what? Before fitting into aircraft, it has to, I told any component which is being used in aircraft or in aeroplanes or fighter planes or whatever it is, it will undergo a series of testing things. Okay, series of testing. So agency called semi lag. Similarly, uh, for the civil aviation, mm, what is the authority? Semi-lag for the military. Okay, semi-lag for the military certification agency, and for the civil, it is something like a D under. This comes under DRDO. Which agency it's supposed to test? No, what is that? Any idea? Do you have? Mm, that authority is called testing authority. Who's that? Semilog for the military, this one. And for the civil aeroplane applications, there is another team. Okay. So these people will actually, you have to take the radar to them. They will come and certify it. Then only you can put it in the aeroplane. So while testing, no, simply they will reject it. Simply they will reject it. So even though you have spent around 5 crore, simply, okay, if few cracks are inside, what they will say, simply they will throw the component away. Is it feasible in practically? After I made 5 crore, spends 5 crore, the component is having this kind of problem. No, it's not possible. Then only, okay, this term is coming, damage tolerant design approach. Then what they will do, again, set of engineers are there in HAL. What they will do, for they have every geometry with them. Okay, they have their, because we are making manufacturing the component means obviously we will have the complete finite element analysis and so on. We have all the things with us. So they will, what they will again reproduce the same analysis with the crack. Okay, they will embed the crack inside. What is what exactly the crack? The one which is found using A scan, B scan, C scan. That crack they will incorporate inside the finite element analysis or other testing process. Then they will undergo the analysis. So from that actually they will find the response of the structure, through which actually they will come to know that if you use the original structure or if you use the damaged structure, or okay, so what is the life estimation? Okay, they will make the life estimation. Okay, undamaged structure, I can take 100 sorties of my flight. Once I use this particular damaged one, I can go for 75 sorties. Sorties means what? Flight hours, isn't it? No, fighter plus there's a sorties, or this many hours I can use. So this kind of study they will use, that is called damage tolerance design approach. This study is based on the fracture mechanics theory. This study is based on fracture mechanics. Okay, understood?
Yes, sir.
Okay. Yes. Yeah. DGCA. Have you heard about the term called DGCA?
Yes, sir.
Hmm?
Yes, sir. It's for
DG.
civil aircrafts.
Director General of Civil
Civil aviation.
Aviation. Something. They only will certify a component to be used for aeroplanes. You know, aeroplanes, you know, no, they used to change the component, more often, isn't it? No, what I heard this, the tires, you know, aircraft tires, they used to change, you know, once in a day. Have you heard about that? The tires they used to change at nights.
Yes, sir. Yes, sir.
Similarly, in every aircraft, you know, once in certain hours, you know, this flight supposed to go to overhauling. So there, whether the component is perfect or not, according to the given the sheet, the what you call that. Suppose if a Boeing or a Airbus, if you're buying these things, no, along with that they will give you the chart, that is replacement chart. That means they will give you this has to be replaced once in this many hours. That means tire has to be replaced every day, or that particular flight has been flown this particular time. Okay, likewise, components you have to replace, whether it is intact or not, you have to replace it. That is where the aircraft companies are surviving. Otherwise, simply they are selling the aircraft alone. A company cannot survive, Boeing or Airbus or whatever it is, because something like they are selling the flight just merely without any profit. How they are making profit? The overhauling process. Overhauling. That is where your jet airlines lost. They have loss, huge loss, and Malaya Airlines. Which one? What is the Malaya's Airlines? Kingfisher, isn't it now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Kingfisher lost a lot of big loss company. Why? Because they cannot run the show, because such a huge amount you need to maintain the aircrafts. So it's not like our regular buses. It is going to something like once in year, all the commercial vehicles, no, it is going to RTO check, no, for FC, what they call FC. Likewise, overhauling is important in aircraft or fighters. So in our FC, simply we repaint the tires and we'll take it. You bribe it, that fellow will give you, okay, you can run the thing. Likewise, but that kind of approach is not possible in this kind of aeroplanes or fighters. They are all very stringent process. DGCA will not allow if they have any doubt. Semilog also they will not allow. When you even the damage tolerance study you make, if they satisfy only, they will allow the rudder to be used in the aircraft, fighter plane. So that means what? An engineer like you have to make a pakka analysis, pakka prediction of the age of the damaged structure. This is very, very important. How you can do that? You have to understand the subject. You have to understand the finite element. You have to understand the material behavior. You have to understand the mechanism. You have to understand the aerodynamics. So with all those things only you can approach your things. You can make it to the semi-lakh people. So this is my approach. So that is how your promotion inside. How Abdul Kalam came to that level. He was something like a design engineer in rockets manufacturing. Slowly he started his career. He came to up to the level of president. That means your approach, your task, you in aircraft, the rocket analysis and all, he was started as a simple engineer, but because of his approach, he was involved in many areas, and he used to go to different departments just by his own self motivation, though he is working in a particular department, no, since he was a bachelor then, so he had a lot of time. So how he utilized it those times, he used to go another division there, voluntarily he helped. Why? He from that he has learned many things. What happened ultimately? One particular day, it made him as a director of the project or manager of the project. Okay, then scientific advisor to India, then president of India. So your approach is important. Your learning process is important. Okay, right. So this damage. Now you understood what exactly the damage tolerance approach. Is it fine? No, you got it. No, what exactly the damage tolerance approach?
Yes, sir. Yes, sir.
Yeah,
Yes, sir,
this is
I got.
important. Okay, this is very, very important. The damage tolerance approach. That is
Sir,
what. Yes, ma. Go ahead.
one small doubt. You said that
Mm,
the imperfections or the flaws or the discontinuity in a
mm,
material
mm,
appears because of service or some other reasons. Could you repeat
mm.
that part? What
Yes,
all
ma.
reasons?
Indeed. Damage can cause inside the structure for many reasons. One is manufacturing defect. Another
Okay.
one is when you manufacture different component, you're assembling it. By mistake, one hammer might have fallen on the structure, or some other component fallen on the structure. It may cause some damage inside. In that time, you may not notice that particular thing. Like people know, bike people know, they may fall. They might not. They may have some kind of head injury, but simply they ignore it. What will happen? That head injury which is inside, over the period it will cause a brain tumor. Likewise, structures, some object might have fallen on the structure. Suppose you take a composite wing, when you are fabricating or when you are attaching to your things, by mistake is some other, because if you see the plant and all, huge things, so many items are all flying, the what manufacturing plant. So something might have fallen. So that may cause damage. Or something like over the period, damage may happen. Initially, you won't find anything, but in the service load, damage, because there'll be some weak point. How that weak point could be? It could be some material, lighter material might have accumulated in that particular place. So some kind of things. So many reasons a flaw could happen inside the material. Am I answered your question?
Yes, sir.
Yeah, right. So the damage tolerance, it's a kind of approach we are making on the damaged structures to be used. So this damage tolerance requires an understanding of how an inherent flaw grows in surveys and when it will become critical. That is what all it is important. That is what all it is important. Uh, So what exactly that? Suppose this is I have a specimen. Okay, there is a initial flaw. There is a initial flaw. So once I apply a load P, okay, the P is acting on my structure something like this. Okay, so if I want to use this particular component with this particular flaw, so because of load is happening, no, so the flaw will grow, isn't it? No, it grows. We don't know where it goes. So and also when it causes a severe damage. So that is what the damage tolerance approach requires understanding how an inherent flaw grows because it is okay from one point how it is growing. Okay, in the service. This is service load because initially only up to here because of service load it grown. What is service load? Let us say flight. Okay, rudder with a small crack. I'm just allowing. Okay, every day morning, the pilots used to take the fighter and goes for a round and come back. Isn't it a practice training every day? So one day half an hour, second day half an hour. So the load up and down, isn't it now? Likewise. So what will happen? This particular flaw, the crack, that particular round, what will happen? A stress concentration will happen. Okay, failure happen, stress concentration, failure happen. It's a growth will happen. So keep on, it is growing. So this is a study. The damage approach means this is a study. And before study, I should have appropriate knowledge. Just like that, one cannot study this particular thing. That is what it is saying. And also, one day it will become critical. One day it will become critical. You might have heard the news, when the flight is landed, the flight is broken into two pieces. Have you heard about these things? Or when landing, what happened? One of the engine had fallen. When landing, one of the wing got broken. Have you heard about such newses?
Yes, sir.
Hmm? All
Yes,
of
sir.
you?
Yes, sir. Yes, sir.
Yeah. All it is because of the fracture. All those problem is because of the fracture. They knew there is a problem, but over the period the things will grow. One particular day things will happen. But normally in aircraft they don't allow such things. But what will happen without the human this thing something would have happened, and that particular day, suppose if I estimate the fracture will grow maybe next 3 years it may take. But my estimation is the flight is been handled by highly well experienced flight pilot. But what will happen, unfortunately, some kind of rough pilots may be there. That you might have noticed while you happen to be in the aeroplane for quite some time. Somebody will land very harshly. Somebody will land very smoothly. Have you experienced such things? Have you noticed such things? The question to you.
Yes, sir.
Yeah. So because of that nature of the flights handling the equipment, the growth rate will be higher. Then one fine particular day, probably you might have heard that, um, uh, sometimes the new pilot is taking the flights to a new maybe old pilot to a new location like a Mangalore kind of tabletop airfield. Do you know what you mean by tabletop airfield?
Sir, the runway might be small.
Yeah, it is actually a hill. Basically, a hill is been cut into flat surface. Okay, a
Yes.
hill is there, no? It is flattened. This is runway. Can you see
Yes.
my pen?
Yes, sir.
Okay, this portion removed. So once the flight goes 1 feet beyond, it will fall down. Okay,
Yes.
that's called tabletop runway. Okay, so by mistake, the highly experienced known pilots only used to go to Mangalore. Okay, if a new pilot comes, means they may need a good actually understanding about that thing terrain. Then only they will land. So by mistake you land some feet away. Then what you will do? You will use all your muscle power. You pull this one, that one, and all these things. What will happen? A sudden shock will comes, means already there is a crack through damage tolerance approach we are using. And the this particular A320 flight is more often coming to Calicut airport. So good experienced pilot itself, they take a lot of effort to stop the flight. But unfortunately, on that particular day, totally unaware pilot. So everything makes structural load high because the landing, they use equipments, braking, everything cause the structure to get more responses. So the crack will grow faster. So that is the reason one particular day, the wing will cut into pieces or the fuselage will cut into pieces. Even, have you heard about air pockets?
Sir,
Air
are you asking
pockets.
generally for a material, sir?
Yes, ma. This is air pocket in the sense it is something like when the flight is flying, no? Suddenly
Yes, sir.
one zone, no air. Have you heard about that? What will happen to the flight?
Yes, sir.
Yes.
Air pocket turbulence, they call it.
Suddenly it will fall 10,000 feet or whatever it is. The next where you are getting the air cushion, suddenly it will fall. Have you heard about that? This is usually happens once yearly, 2 or 3 times happens. Some part of Singapore route or sometime. No, it will not happen every route because the meteorological department used to give the data to the pilots that possible air pockets. Then by the time pilot will usually lift or down the flight and he will nicely take away. But sometimes people may miss it. That time what will happen? Flight will suddenly it will fall. That's what when you see that, it is always better you have to wear a seat belt while you are flying. Okay, it is always advisable because only when you want to go to bathroom and all, that time you can unseat your this one belt, unplug. But it is better. Why? Because any time if it happens, even sometimes it may cause severe fatal damage, because once you are walking inside, suddenly the flight is falling now. So why I brought that particular topic here means these kind of damage is there, and it grown in a particular length, and it may not be critical at that particular time, or it may be a critical one which I'm supposed to change within 1 day or 2 day. Suppose I know as a flight maintenance engineer, but unfortunately on that particular day, if this flight is caught inside any air pocket, means the flight will go into pieces. Flight will go into pieces. This is what some kind of problems. Probably 4 years or 5 years back, there was a flight from Argentina or Brazil to UK. Simply a flight was missing in the airborne. Have you heard about that news? No.
No, sir.
Just you look, okay? You can make some kind of literature review or news review. You just check it, okay? What happened to, okay, a flight? It was from Brazil to London, okay? You just check because suddenly the flight was disappeared. So what they said, this could be because of air pockets. Because of that, flight might have broken into pieces. Okay, this is something like structural failure. But if you take some Malaysian aircraft, no, somewhat some MH flight, no, that story you know very well, I hope. Malaysian Airlines, no, 5 6 years back, so the flight commander itself took it inside the sea. That story you know or not?
Yes, sir. Yes, sir.
Huh?
Yes, sir.
Yeah, still they could not found, no, where that
Some
missing flight.
Some remains they found, sir, but they
Yeah,
didn't
yeah,
find
but
them.
still they are not very clear that. But those things, okay, men made problems. But these things, this one, you try to get something on that. That was a recent big accident. Okay, it could be or it could be air pocket problem, or it could be some kind of thunder might have affected. Okay, the lightning thunder could have affected. So
Yeah.
in situations, if the flight is having this kind of flaw, then it is a problem. That is what Lufthansa or something like British Airways. Why actually their flights are so costlier? Because their flights are very new, or they will simply replace the flights quite often. But if you see Air India and other things, the Tiger Airlines, Go Airlines, they might have used the used airlines of Lufthansa, this one. Is it something like our car industry, like used car, something like that? So that is the reason people always very big shots. No, they used to go by Lufthansa, or they used to go by British Airways, because they are all like using fresh pieces. Okay, so you may expect less kind of damage, something like that. So this is very important in analysis. Why I'm telling all these stories means fracture is important, and without fracture, it is very difficult to make a structure. Even if there is a damage, can I throw the particular component? No, because once you go back and see the flight manufacturing industry video and all, one wing itself, thousands of people used to work. It is something like so huge. Thousands of equipments will be inside. It's so huge manufacturing. The composites, something like. So you cannot simply throw a component. You have to have something. You have to have the redesign. Something like the only things will go. That is the importance of that. So. In any crack problem, you have to. So time up, no?
Yes,
Hello?
sir.
Yes, sir. Yes,
Yeah,
sir.
yeah. So can we stop now?
Yes, sir. Yes, sir.
Or can I finish this slide? This summer.
Sir, I
You have
think
a
we can
class?
stop it today, sir.
Okay, pa. Oh. Just a minute, I'll
Yes.
take the attendance. So only one guy is missing, isn't it? No? Absent. One.
Yes.
No, two. Two. Dave is
Two.
roll number 2.
Roll number 2 and 12, sir.
Yeah, yeah. 1 minute. Okay, pa. Now we will leave.
Yes.
Thank you.